Hello, I would like to welcome everyone to the presentation on water mitigation. All you need is hot, dry air. My name is Chris Ward. I've been a deflet technician for over 8 years. The reason with this title is that's all you need is hot, dry air. You need the air to be hot, you need the air to be dry, and you need the air to be circulating. Let me pose a question to most of you in the audience. If you came upon a water loss either in a house, a business, or a school, what would be your first response? Your typical answer would basically be, take everything out. Remove the carpet and pad, remove the sheetrock, remove any other materials that may lead to secondary damage, such as rot, odor, mildew, and mold. But what if I was to tell you that there are equipment that is designed to dry these materials out to where you can save them and save money on any kind of repair work that could be done? That's what I'm here to tell you today. We're located in a testing facility at a local restoration company. I'd like to thank them for allowing me to use their facility today. So, what do we do when we first come in? We need to identify what is wet. And we need to have a set of tools to do that, because one, looks can be very deceiving. First thing we're going to use to check the floors, mainly carpet and pad especially, is this guy. It's a hydro sensor. Okay, this is your hydro sensor. As you can see, has 2 prongs that come out right here. These are designed to go through the carpet and pad without penetrating it. Just come to the carpet, poke it in, and you're done. When you hit a wet area, you'll hear this. That allows you to know that that area is wet. Why am I testing it on myself? Because everyone knows the human body is 70% water, thus has moisture in it. These testers work is because they use an open circuit system, and they allow the moisture in your body and in materials to close the circuit, like so. So we've identified that this area is wet. It could possibly be because something as simple as a small pipe leak or an aquarium leak. So after we've identified that this carpet is wet, we need to check other materials. That's when we reach for this guy. This is a Proto Meter. This here is your Proto Meter. As you can see, has a penetrating at the top, non-penetrating at the back. You see it has a digital readout. It's designed to read materials as sheetrock and wood to let you know if there's moisture trapped inside of it. When you come across an area that's wet, you're going to hear this. That was the non-penetrating side. It also, like the hydro sensor, has a penetrating side to get a more accurate reading. This is a digital readout. There are some that come with an analog readout, but I find the digital readout has a clearer picture and a more precise number. Therefore, you're not confused when you're trying to figure out what percentage of the material is wet. So when using it, you're going to take it on the non-penetrating side, and you're going to go down, and you're going to go up. Why? Water has a tendency to weak up. We want to make sure that we've identified how far that water has weaked up. Once that's done, well, we've identified the area. How do we get the water out? Well, we have physical water on the floor and the carpet and pad. That's 80% of your problem right there. So we're going to take a weighted extraction machine in order to get that out. But I know you're thinking, why use a weighted extraction machine when I see people using what's called a carpet wand? Just a large tool that extracts the water across it. Simply put, that doesn't get to the pad, and we're here to save everything, even the pad. The pad is like a giant sponge. If you don't wring that out, you're doing absolutely nothing. This machine right here is your extraction machine. It's weighted at 250 pounds. The reason it's 250 pounds is because that's what it takes to wring out a carpet. As you can see, it does have a motorized motor on it. Why? It's really, really hard to push 250 pounds across a wet carpet. So, it has a motorized motor. On that front wheel of the motor is a cylinder wheel with holes in it. That way, as it's going across it, it's extracting. How do we extract it? Well, it's through this hose here that's connected to an outside truck-mounted unit that's able to produce 500 psi of suction power. Let's take a look at that extraction machine, shall we? Alright, this here is our truck mounted extraction machine. This is what we're going to use to pull the water out of the building. It produces about 500 psi of suction power. First thing we're going to do, we're going to take the hose that's connected to our weighted extraction machine, we're going to hook it up to the inlet line here. Once we have that done, then we're going to turn the override switch to prime it. We're going to turn it on, start her up. Once it's started up and it's fully going, then this little lever here is your throttle line. We're going to push it all the way in to maximum full power of throttle. Why? Maximum efficiency means maximum results. So let's go back and start extracting. Okay, now that we have that extraction machine up and running, we can now start extracting. So we need to perform what is called a pass. That is a forward motion forward, and then that's also one coming back like this. It's self-propelled. You let the machine do the work. Let's work smarter, not harder. So your typical passing is going to be about 2 passes. That's forward and back 2 times. So that's 2 forward, 2 back. Now, some carpet and pad may require you to extract maybe 3 to 5 passes. But once we have it all extracted, how do I know that it's completely extracted? Well, you apply pressure to it by simply kneeling on the carpet. Like I said, it's a pad. It's a sponge. It's going to transfer the moisture into your pan slab. If you see that there's very little moisture on there, you've gotten all the machine's going to take up. So we now have successfully removed 80% of the moisture we need to be drying. But in order, we need another tool to help prevent any kind of damage to the carpet, because we did have 500 psi and 250 pounds just roll across it. So we use a carpet rake. You just rake across what you did, and it's called relaxing the carpet, because we don't want it during the drying process to be stressed and then end up being stick and brittle. Therefore, when we do that, we've completely negated the whole purpose of what we're trying to do. So you've extracted the water, you've relaxed the carpet. Then what's the next step? Air circulation. We need stuff to blow the wet moisture off the material. What do we get? We get an air mover. This is an axial design fan, but it's way more powerful than what you could find anywhere else. Most of you have probably seen the squirrel cage fans that you see. Those are designed only for drying carpet. We're not drying carpet. We're drying carpet and sheetrock. We need something designed for that. As you can see, this fan has a teardrop design to it. This bottom piece right here at the bottom is actually designed to blow maximum air at that point. So we want maximum efficiency to get maximum results. So this goes on the wet structure. You place that so as an angle, because it's going to hit and go down the rest of the wall. This fan is good for at least up to between 14 and 16 feet of air drying. So, like I said, it's simple. There's no batteries, nothing. Just plug it into the wall, like so, and you turn it on high. Why do we put it on high and not low? Maximum efficiency, maximum results. Okay, so we have our fan up and going. But all we're doing is just blowing moisture around the room. It needs a place to go. We need the dryness. We need the heat. That's where this comes in. This is a 200 max low-grain refrigerant dehumidifier. Why a low-grain refrigerant dehumidifier? Because this is designed to strain out the air. Like we've strained out the carpet and pad, the air needs to be strained out too. This works simply. The air comes in through the top. It goes through a cooling core system that you would basically find in any AC unit. What it does inside is it drops that air down to its dew point, and it strains out all the water. And then there's a small exhaust on the outer side of this machine. On the outer side of this machine that blows out hot, dry air. Why? Because why have it on the bottom? Heat rises. So we're actually force feeding all of this here to come up and back into the machine. Now, this machine is different than any other dehumidifier you're going to find. Due to the fact that the level of moisture is going to pull out the air, it does not have a recovery tank on it, which means you're not going to be, because you're not going to be turning this off and dumping a tank. There's too much water. So it has what's an automatic pump out system. Inside of it is a 5-gallon tank. Once it reaches 5 gallons, it's going to pump it out. For this demonstration, I have put the pump out hose into a small bucket. What you really want to do is find a drain for this. That's why if you have a drain, you don't have to worry about dumping out a recovery bucket. So we also plug this guy in. So I'm going to come over here, plug it in. After we got it plugged in, there's really only two switches, an on and a manual purge. Why a manual purge if it's automatic pump out? Well, because you want to drain this before you move it at the end of the job. So you're going to drain it when you're done. That way you're not sloshing around water when you're done. So let's see what we have here. We have our dehumidifier going. We have our wind going. How do we make sure that everything's working correctly with inside the air? We reach for this final little guy. This is a hydrometer. Its whole purpose is to measure the air. It's going to give me the temperature. It's going to give me the relative humidity. It's going to give me grains per pound. The three basic things we're going to need. Temperature, the warmer it is, the better drying we have. Relative humidity in a home is between 40 and 48%. That's average. We're drying out this room. We don't want average. We want below average. We want that relative humidity as low as possible. The lower the relative humidity, the drier the airspace is. So we want that number to be anywhere between 25 and 30. At the most, below 40%. Now, how do we measure that? How do we know that everything's going to happen that way? We get a baseline reading from outside. Then we come inside the home. Typically, you're going to have an open drying system, which means you're going to be in a hallway, you're going to be in an entryway, you're going to be in the living room. You're going to get a reading in there. The reading inside the home, if set up correctly, is going to be lower than outside. Like I said, we need to have comparisons through this whole process to make sure we're creating the perfect drying chamber. Now, if you're able to, like in here, come into a bedroom where you can seal it off from the rest of the house, you're going to want a measurement from inside the non-affected area so you can compare it to the air inside the affected area. If the air inside the affected area has numbers higher than the non-affected area, something's wrong. A window's open, the machines aren't working correctly. There's another leak somewhere adding moisture. Once that's been done, then you're going to test this guy. The best way to test it is to come down here and get a reading off the exhaust. Why? Because that's the air we're putting back into the room. So, once again, that number off that exhaust should be way lower than what you get inside here. If it's not, this dehumidifier is not working correctly, you need to find another one. Why do we take all these readings? Why do we measure everything? Simply put, we want to be done at the longest in 5 days. Typically takes between 3 and 5 days to dry everything out. The way we check this during the monitoring process is we have paperwork, so we have comparing from day to day because things change. And this first sheet of paper is your monitoring sheets for the readings. This is your daily record sheet. And as you can see, you're going to put the date, name, and all of this here. Outside readings, witness readings, unaffected area if available, and the dehum. This number here at the end of the dehum we're going to pay attention to as it is the grain depression. This needs to be lower between this number and this number. Said you should have a negative number. There should be a negative difference between the two. If not, this machine is not working correctly. Your second deal, this is going to come to your structure that's wet. This is your moisture structure sheet. You're going to map out all the areas that are wet here. You're going to label the areas on this side, bedroom A, B, C, and D. On this first slat, you're going to put the inches, how high it is in the wall. The second slat is going to be the percentage off of the Proto Meter. As this continues through the day, those numbers need to be getting smaller and smaller and smaller. Like I said, that's why the digital readout on the Proto Meter is a whole lot better than an analog. So you can get it, you don't have to guess what the percentage is, it tells you automatically. So that we want to get is 0 inches at 10%. Like I said, we don't want to get it too dry, but that will also lead to problems. So we also have numbers to gauge that. So you have your reading sheets filled out, you have your air going, you have your dehumidifier going. Within 5 days, all of this should be dry. And when it's dry, you're not going to worry about odor, you're not going to worry about mildew, you're not going to worry about mold. So, like I said, these are equipments that you need in order to dry something out successfully without tearing out anything. You have your extraction machine to pull the standing moisture out of the room the first day. The rest of the time you have your fan creating your wind speed, your air, and you have your dehumidifier that creates the heat and the dryness. Thus, you have your 3 elements to dry it out: hot, dry, air. I'd like to thank you all for coming. That concludes my presentation, and I hope you've learned something today. Thank you.